We will now take a look at the RBD material fracture node, which is one of the latest additions in Houdini's destruction workflow. So as you may know by now, I like to start with a very simple exercise just to understand the principles, and then we will jump into our main destruction scene to build up on our new acquired knowledge. Let's start by creating a simple box. So control click on the box tool, dive into the geometry node, and let's change some of the box parameters. For example, the size to 6 on X, 2 meters on Y, and 0.4 on Z. Let's also recenter the object 1 meter above the ground, just to have a basic wall to work with. Now, as usual, we will create a volume from this polygon. So I will lay down an ISO offset node. Remember, you can also use a convert VDV node. For this case, this is fine. I will use a uniform sampling division of 60. Then I will scatter some points. And make sure we have less points. Probably 10 for now is fine. I may change the seed as well. Now I will look for an RBD material fracture node and connect the wall to this node. I will also connect the scattered points to the fourth input of the RBD material fracture node. So you will notice that now we have a few pieces generated. And as usual, let's add our exploded view. Connect the first input or the first output of the RBD material fracture node to the exploded view. And let's reduce a bit the uniform scale to 0.2. Right out of the bat, we have a few cells that look a little bit like the Voronoi cells that we created with the Voronoi fracture node. But in general, the RBD material fracture node is much more powerful. So let's take a look at some of the parameters. I will select the node. And the first thing you'll notice is that we have a material type. And by default, it's set to concrete. So let's first of all explore the concrete parameters, and then we will take a look at the glass and wood. A small note before we continue, it doesn't really make a difference for now if we have this fourth input connected. So actually, I'm going to press Y and drag just to disconnect the scattered points. So notice how the cells haven't changed. Let's take a look at the parameters without this connection, and then I will explain how this connection works. So notice how by default we have a fracture level 2 on. This tab has some parameters for fracture level 2. For now, I will delete this level and add it back later on. So click here on the remove icon, and I will just work with one level for now. So I will scroll down a bit. And notice how, first of all, and probably the main option that you want to check first, is the scatter points is set to 5. If I increase this scatter points, say to 20, I will have more pieces, just like as in the Voronoi fracture node. I can also change the seed if I'm not happy with the arrangement of the pieces. And notice how we have a scatter from, a volume, or an attribute. To use the attribute option, you need to have a density parameter on your geometry. But for now, we will work with this default volume option. And this is doing something similar that we're doing here with our ISO offset or with the create VDV from polygons node. So first of all, it generates a volume, and here we have some options for that volume. And then it scatters a few seeds to create the Voronoi cells. So the main parameters on the fog volumes are the resolution. In this case, 75 is usually fine. If you increase this value, you will have a higher resolution volume, but a slower result. You can also increase the frequency. And of course, as usual, you can offset the pattern to achieve a different cell distribution. And the main objective of this volume noise is to have a fairly uneven distribution of points to avoid even-sized cells, which usually looks unnatural. Let's go back to the cell points. And remember we had a fourth connection on the RBD material fracture. Let's connect back the scatter points that we had previously. And notice nothing new has happened. So by default, the RBD material fracture uses its own internal points to create the cells. If we reduce the scatter point to 0, we now have our original wall back to where we started. We could click on the input points to create our Voronoi cells. So if you select the scatter node and change, for example, the count or even the seed, you will notice that now the RBD material fracture node is using the scattered points to generate the cells. So let's again reduce the number of points, say to 20, and go back to the material fracture node. And let's take a look into a few of the other parameters. So I will click on the chipping tab and click on the enable chipping option. So notice how a few new cells were generated on the borders, or actually on the corners of these big cells. And this is nice to add more detail. So you could change the overall ratio parameter to increase the number of chipped fragments. So basically, the larger this number is, the more chips you'll have. Or you could also reduce this number. And of course, as usual, you can change the seed to change the distribution of these new cells. So for now, I'm going to turn off this option. And here we have a very interesting option, which is the detail. So click on the detail tab. And here you have two options, the edge detail and the interior detail. So first of all, let's start with the edge detail. I will turn this on. And notice how, first of all, the interior faces have been subdivided. So now we have much more points and primitives on the inside geometry, and this is controlled by the detail size. So for now, I will increase this a bit to 0.1. And the lower this number is, the smaller these triangles will be. Another very important parameter is the noise height. So the larger this value is, the larger will be the angles that are generated here on the edges. And this parameter is very important to avoid the geometric cells that are usually generated by the Voronoi fracture. So if you take a look at the edges now, they look much more natural and look much more like a concrete or a rock material. So the noise element size can change the detail in this pattern. So the smaller this value is, the smaller the detail will be. Of course, if you have very large chunks, you might want to increase this value. For now, I will go to noise height of 0.15 and noise element size of 0.2. So this is looking very nice. Of course, we could increase the detail, but I will go with this for now. Now let's take a look at the all-important interior detail. So I will click here on the interior detail option. And you will immediately notice that some detail was generated on the interior faces. So let me just click outside of the node to be able to see the detail here. I will also zoom in. And the parameters here are very similar to the edge detail. We have a noise amplitude, which will increase the height of the noise. So this by itself is looking very, very interesting. We can also change the frequency of this noise. So if I increase the overall frequency, I will have smaller patterns. In this case, I probably would have to increase the resolution of the interior faces. Let's try increasing to 0.05. Actually, I will go lower for now to 0.025. Of course, this will be slower, but we will have much more detail on the edges, or actually on the interior faces. So let's reduce the frequency just a bit. I will also reduce the noise amplitude. And this will greatly increase the detail in your fractured pieces. And now if you're wondering if this is probably too much detail on your geometry, one of the most interesting features of the RBD material fracture node is it's generating a low resolution mesh based on the original Voronoi cells that are generated. So let's lay down a null object. And let's connect the third input, or actually the third output of this node, which is called proxy geometry, to this null. So if I click on the visibility for this null, you will notice that we have the original low resolution cells that were created before adding the detail. So let's connect this to the exploded view. So in the end, when we are creating our RBD simulations, we could use the low resolution version of this fracture object and then switch to the high resolution version for rendering, which is a very powerful workflow.